morning, everyone. Thank you so much to the PWA Summit organizers for giving us the opportunity to share our research with you all. We are incredibly grateful. Today, we will discuss performant progressive enhancement and how to integrate it with PWAs to provide support for every user. To start off, I would like to provide some background on a research project that we are working on in collaboration with Howard Brown Health. We are creating a mental health self-compassion intervention app for sexual and gender minority or SGM individuals with new HIV diagnoses. We understand that being connected to healthcare professionals and coping with HIV is difficult and traumatic, which usually leads to a lot of these cases going untreated. Thus, our goal is to reduce self-stigma and also provide treatment and resources to the SGM community. To do that, rather than an in-person clinical setting, we are going for an app-based intervention approach, which has shown efficacy in improving a patient's responsiveness to their own mental health concerns, decreased a negative mindset, and has aided with stress, anxiety, and sleep. The main engineering principle that we are implementing in the app is the other progressive enhancement. And what we mean by progressive enhancement is ensuring that our design is functional to everyone, no matter what device they carry, nor what network they have. The idea of every byte matters means that when a user has a network connection, we are putting every single byte to use to power up and load our content in the background. In doing so, we are making our web app accessible to those who come from all kinds of diverse backgrounds, including low resource communities that may not have access to a reliable internet connection or have small yet expensive prepaid data plans. We can also balance incoming requests against a network that could be unavailable. And not only does every byte matter, but every byte counts as well. Keeping our users in mind, we want to minimize the amount of resources and money we spend in our progressive enhancement design. We can do so by limiting the data transfer required, which means implementing lean semantic HTML, bespoke CSS, vanilla JavaScript, native web APIs, and feature detection. Without the use of outside frameworks and extra libraries, we can somewhat control the amount of data we are working with.
Great. Thank you so much, Kinza, for that introduction to our project. And yes, thank you to the organizers for making our talk available as part of this really important summit that we're having. So I want to pick up with exactly what Kinza was talking about every byte mattering and every byte counting, and really talk about how we're using progressive web apps as a concept to inspire all of the different experiences of this app. I think it's easy to get into a mindset where when we're thinking about progressive web app, then we're immediately thinking about service worker and manifests and sort of all these things. But one of the things that we're trying to do through our project is to challenge the idea of what performance means. Too often, I think, as developers, we're already starting from a pretty performant place where we've got fast internet connections. We've got the latest browsers that are able to handle service workers, to do all kinds of caching and things like that. But rather than thinking about performance as like a speeding up and making an already good experience better, we want to think about performance as something that expands outward and includes more users and more devices. And for us, that really starts at the level of requests and URLs. So I'm going to talk a little bit about that. And in getting to requests and URLs, we're going to talk a little bit about resource redundancy because we want to have it both ways. We want to have both a modern application that is using lightweight data serialization to sort of reduce the overall footprint of bandwidth that we're using. But we also want to make sure that for devices and users on networks that can't take advantage of that, that we're still falling back and providing the kind of experience that will work on all of those different devices. So the way that we frame it, performant progressive enhancement, again, thinking about performance as this expansive and inclusive move rather than just a speed it up and impress ourselves on metrics moves, requires thinking about URLs and requests before a single byte has been loaded. And in doing this, when we try to write a progressive web app that's built with modern construction and is using um, JSON payloads and things like that, we tend to work with logical URLs. And I'll get to the client side in a second, but it's always worth a refresher that we've long had logical URLs on the server side. And of course, Apache's mod rewrite is the long-standing classic example of this, where we take some nice looking URL that's easily shared, that's easily transferred from one device to another, and we do something fancy to rewrite it on the server side. But on the client side, we've got logical URLs that have traditionally relied upon URL fragments, right? And I think Twitter was part of the one that kind of lead the way away from URL fragments and more towards true URLs, what I'm calling URL or true URLs or URL paths. But we've used URL fragments historically to trigger JavaScript and to intercept requests, do things like that. And of course, the fragment had a lot of appealing features for any kind of JavaScript powered app, but certainly progressive web apps. When we use a URL fragment, it doesn't trigger a brand new request. So we're not doubling up, we're not losing state in between different kinds of loads. They do appear as part of the browsing history, which is sometimes surprising when you think, oh, I'm just going to move through these different fragments. And of course, there can be cases where that's a problem. For example, if you've got an image carousel and people are clicking through it and you're using URL fragment, they might be surprised to discover that they have to hit the back button once for every single image that they looked at. So that can be a tricky issue as well. And of course, if you've done any research at all about URL serialization and the caches API and the service worker spec in the last 5 or 6 years, there are different implementations out there in terms of how URL fragments are handled when matching against the cache. In the spec now, they're supposed to be counted, but they don't necessarily get passed on to the network. You can use a URL serialization flag to disallow matching the fragment on the cache, but for us, it's like, well, we either have to build in a whole bunch of logic or take a different move. And what we want to do is actually move away from the URL fragments and think instead about logical URLs on the client side. And part of that is going to be using, of course, the HistoryPushState API, which is surprisingly old. I'm in my professional day job, I teach web design up and down the stack, and I have a lot of beginners but I also have a lot of advanced students too. And it's surprising how few people know about the history API and the push state. So if you haven't done that or you need a refresher, go back and look at that, but also check out all of the browsers that really support the history API and particularly push state. As cool as push state is, because it allows us to sort of have our cake and eat it too, we can rewrite our URL in the browser, we can add it to the history, but importantly, we're not triggering a fresh request. So we can, again, use these logical URLs on the client. We do get some additional problems with them though, right? On the client, something like /resource/1 is going to be something that sets JavaScript and the service worker in motion. But if we're outside of a JavaScript context or a service worker context, resource 1 as a direct server request can return a big old 404. So we want to try and think a little bit more about how we work with path-based logical URLs and think of them as partially a tricky position on the client side, and that outside of a service worker, a request can be off to the races to the server before JavaScript can even find its shoes. So if we're writing some DOM script or something on a fresh request that's expecting to act on this URL, that's a problem for return visits, but it's also a problem not just for return visits, but for feature detection as well. We might say, oh, we've got a service worker available here and we support the cache API, so we're going to do all these things. The problem is if you've got a user who's got a phone that has a modern browser like that, particularly in the populations that we're building our app for, they may have their phone, like so many of us, full of movies and images and apps and things like that, so that there's not actually as much cache there as we expect to be able to work with. So we want to make sure that these logical URLs also have a counterpart on the server, right? And that includes using bookmarks and sharing URLs to other devices as well. So our sort of big ponderous question here is, do client-side logical URLs break the web? And the spoiler, of course, which I've pretty much given already, is that, yeah, they can, but it depends how we engineer these things. right? And so our conundrum here is that server-side URLs should always return the same response to a GET request, right? This is basic HTTP. A GET request to a server is always going to be stateless. The problem is that on a client, it's completely the opposite. If we're using logical URLs through push state or otherwise, these are always going to be state dependent because the state is necessary for us to intervene so that we can use JavaScript and the cache API, including in a window context, not just a service worker, any other web APIs, and of course our cache contents as well. So the question that we have and that we're working towards some more workable solutions is how do we address this conundrum? And the way that we've kind of gotten to that is to talk about resource redundancy and doing our best to fulfill requests from all clients as best as possible given a particular set of networking conditions. That means reconciling our logical URLs. We want to present logical URLs that only match server URLs. We want to do all of our request intercepts and caches match in both the window and the worker scopes. There is a vanishing number of browsers out there that actually shipped with the caches API before they had full service worker support. There are also conditions, again, with different network traffic, congestion, things like that, where we might have access to the cache in the window, but not necessarily in the service worker because for some reason the service worker doesn't load. So we want to be able to intercept those requests and take advantage of whatever APIs we have available to us. And of course, in doing all of this, we sidestep the question of URL fragments and cache matching. One of the things that's a problem with a fragment-based URL scheme is that those fragments, regardless of what the service worker does, regardless of what the cache API does, the fragment is not passed to the server. So we cannot reliably use URL fragments and hope to get a response on a return visit or on a shared link or something like that. All right. So to return again to our notion of performant progressive enhancement is that the server can always deliver a complete request. And here I'm really focused just on the content. There's plenty of room to talk about assets and CSS, but I'm really, particularly for a mental health intervention, the most important thing is the content and making sure that our users are able to access that. So we look to make sure that the server can always deliver a complete resource on any given request, and that the client is always going to be carefully and progressively enhanced, doing some kind of feature detection to sort of build upon those lower level things. It's basic progressive enhancement, but we're thinking outside just of a fully installed progressive web app and thinking about this for all users. And of course, we still want our lightweight content serialization and keep that in the mix for all capable devices. While it's the most accessible thing to have these resource matched URLs, we would rather just transfer a JSON payload and allow someone to just download that once and work through the logical URLs and go through the mental health intervention than to have to risk a request every time. But we're still making sure that that individual request is in the mix for us and for our users. So as we're thinking about this, and as we're thinking sort of beyond the fully installed progressive web app or a progressive web app that for whatever reason doesn't have the disk access for caches that it needs, or God forbid, I'm the only developer here that does this. Occasionally, rumor has it, developers sometimes accidentally push broken JavaScript. And the problem in a service worker context is that if you're not immediately taking control of the clients, then your users have to live with your sadly early deployed JavaScript that breaks everything. So we can have a lot of different reasons why we get to the three client states that we're sort of focused on in large. So the first is the simple no JavaScript state. And again, that doesn't necessarily mean that someone has switched off JavaScript. It doesn't necessarily mean that their browser is incapable of running JavaScript. It could mean that the network connection is so poor that, yes, we built this wonderful service worker. We've got this great manifest file. We've got all these things. The network is just not strong enough to pull those things down. We're also thinking about JavaScript devices where a service worker is not available for whatever reason, either because the API is not implemented in that browser, or again, because some kind of disk or network connection is precluding us from using the service worker that would otherwise be there. And of course, then we are thinking about JavaScript with a service worker working, but we're sort of working towards that rather than starting with the assumption that, oh yes, we'll have a service worker, we'll have a cache, we'll have all of these great things. Right? So we'll sort of break down what we do in terms of like an initial request. So somebody starts working with a particular mental health intervention, and the way that we're envisioning is that there's sort of multiple steps to that thing. And then, so let me just preview just for a second where we're going. So we've got initial requests. We'll look at like immediately subsequent or navigation requests, and then return requests, and sort of look at the ways that what we're doing is trying to address each of these, and then the places where we're still failing. So with our initial requests, the first time someone goes, with our no JavaScript environment, we're doing HTML, and we're using the relprefetch, and in some cases relnext, not necessarily for assets, but actually for the next logical navigational step in the path. One of the luxuries that we have, and one of the limitations for what we're talking about today, is that we have a high degree of being able to predict, okay, they're on this page of this particular invention, the next logical step is go to the next one, and the next one, and the next one. So in a no JavaScript environment, we're using relprefetch and relnext like that. In a JavaScript but service worker-less environment, we're doing HTML, but then in the window, we're doing a fetch for the JSON payload. And then we can move from individual HTML requests from page to page to just doing what we want to do most, which is to just already have all the content that we need in that JSON file, parse it out, and display it in the DOM. And then, of course, with our service worker, we're working with HTML requests, and then we're trying to use a little bit of JSON prefetch as part of our manifest. And of course, if you've not had a chance yet to experiment with the navigation preload functionality, I know it's shipping in Chrome already, that cuts that weird window down where you're waiting for the service worker to boot up, but you can't yet act on any of its requests. Navigation preload enable is our friend so that we can go from anticipating a particular navigation request to being able to fulfill it from the service worker right away, instead of saying, okay, well, we got to wait for the service worker to boot and then we can actually work with that request. But let me back up a second here, because some of you are probably saying, really? Rel prefetch? So this is an old attribute that goes back to at least HTML 4.01, if not earlier. And what this does is allow you to specify in your HTML some kind of resource that you want to access that you're anticipating will be used next. And there's a whole bunch of, there's preload, there's next, there's previous, all these different ones that we can use. We like rel prefetch because it's the most predictable, but it's also extremely low priority, meaning that if I'm on one page of a resource and I want to sort of prepare the way for the user to get to the next page of the resource because they're on a shaky network connection, and we've got to sort of not only make every byte count, but we've got to make every moment of internet access count. We want to grab that thing as best we can, act on it as quickly as we can, and then, absent the actual cache API, trust that their browser is going to be able to work on that API or on that browser cache itself. We do worry about redundancy with this, that we are waiting for a uniform header for use in our service worker logic. We have our Mozilla prefetch in Firefox, but there is a header that's coming along that will be standard, of course, across all browsers. The nice thing is that when we're using prefetch, not for CSS files or images, but just for our content pages, is that we can actually inspect the mode property on the request from any sort of cache context to separate prefetch requests, which are going to have something about cores or no cores in them, from a true navigation request, right? That's one of the tricks with treating a logical URL the same as a physical one, is that we will be prefetching, but then also navigating to similar paths. And we want to make sure that those work simultaneously together. When we talk about subsequent requests, we're talking about no JavaScript online and offline. Here, we're thinking that, yes, we want the prefetched HTML or the HTML and a subsequent prefetch for the next resource. And if we're offline, we cross our fingers and hope that the browser actually fetches from its own cache. That is an edge case. We have no control over it, but by structuring the app like we're doing and trying to keep it lean and lightweight, we at least increase the chance that somebody somewhere whose network connection fails, even if they don't have JavaScript, they're still going to be able to access that resource. With our JavaScript without a worker, with a worker, we're still dealing with JSON URL or JSON payloads and DOM manipulation on our subsequent nav requests. All right, bring this on home and finish up the talk here a little bit so we can get to the remaining talks in the Q&A. But our return requests, these are ones where it's not a subsequent request, but days or weeks or maybe even just hours pass, and we look at what happens when someone returns to either the middle of an intervention they were working in or working in the app in general. So in a no JavaScript thing, again, we're just crossing our fingers, caching that request in the browser's cache and using relprefetch. With our JSON without a service worker, we're, again, hitting that true URL. We can't count on JavaScript being ready to run with a request before we've even executed anything else in the browser. So we've got to say there's going to be a true URL that's going to get hit on the server, and then we'll do our usual JSON fetch thing. And then with our service worker, we're still in the area of working with a logical URL because we can intercept and do the software caching thing that we do, cough up our cached shell of the app, and move on the way that we expect to. All right. This is where it gets interesting, though, is when we have return requests, but we're offline. With Node.js, if the browser has cached it, if we're very lucky, we'll get a cached response. That's all up to the browser that's working it. The big problem is with JavaScript, but no service worker. If we've got a return request and we're offline, we're going to get nothing because there's no shell to load, so there's no access to any other browser cached resources. And here we're thinking that with a JSON minus or without a service worker, that we're just kind of clipping things off and not grabbing the true URL and caching that. And of course, with our service worker, everything's fine because that's what makes service workers great. So to wrap up, here's our unsolved problems, and hopefully we can discuss this a little bit. We still are looking at extra data transfer. We're making our current things, and we're trying to tell the future by doing anticipated network conditions and making good on a connection when we have it. We've got extra requests, potentially, if we're doing server-side rendering of HTML partials versus just a nice DOM manipulated piece of JSON. Where's the place of relprefetch? Do we just go ahead and, especially for that middle case where we don't have a service worker, but we do have JavaScript, do we go ahead and let relprefetch run? Because that would fix that sort of return request later, because we would be actually having, at very least, at the browser cache and possibly in the cache itself, the original physical URL that we couldn't reach as a logical URL. And then finally, with non-service worker clients, there's this problem, and it's not a problem unique to our app. It's something that we are all challenged by, is that the difference between a truly offline state versus a weak but not unreachable network. And if you've done any sort of service worker patterns where you're trying to hit the network and then falling back to the cache, if we've got a slow network, we wait until it decides that it's just too slow, and then we return the cached response. We've got to figure out ways to handle that particular pattern with some kind of logic. That's our talk and our presentation. Thank you again to the organizers for having us, and we're very excited to have a discussion about this and with the other presenters as well, and hope everyone has a great rest of the summit.